Welcome to the Lionheart Academy. This is Richard Tai. Today we're beginning our lesson 19 in trigonometries. This is function of any angles. Now, as you can see, we're continuing our discussion on unit circle. Functions of negative angles today. We also discussed a little bit today. All right, let's look at this unit circle. So from our last continue from our last lesson, we have discussed how unit circle come about and what does a unit circle mean. Again, the unit circle has a radius of 1. Okay, so the distance from the center of the circle to this order pair to this point is 1. So this point has the order pair of coordinate of 1, 0. So this is the x-axis, this is the y-axis. So basically, in a unit circle, what will happen is that every point on the unit circle is related to their angle, and the coordinate of that point is related to the cosine and sine value of that particular angle. Okay, so any order pair in this unit circle will represent cosine theta and sine theta. Okay. That's the basic foundation of this unit circle. The x coordinates always will represent cosine theta. The y coordinate will always represent the y coordinate represents the sine of the angle. Okay, sine value of the angle. So let me go ahead and just draw very quickly the x and y here. So if we want to, so the cosine theta represents by the x coordinate, and the y value represents the sine theta of the angle. So that means if we look at this chart, we can look, 30 degrees. Okay, that means cosine 30 degrees square root 3 over 2, and sine 30 degrees is 1/2. Now, how do we get those values? We did get them earlier using the right triangle trigonometry to help us. All right, what about the rest of the quadrant? So today, let's go ahead and try to finish our chart here. So what about the rest of the quadrant in this case? Well, let's go ahead and take a look at the rest of the quadrant. Let's look at this angle, halfway between 90 degrees and 180 degrees. Now, halfway between 180 and 90 degrees is 135 degrees. Okay, it's halfway between that. Alright, so let's try to figure out what would order pair for the 135 degrees point would be. Now, as you can see, 135 is a reflection of 45 degrees because this is symmetrical. Okay, this is symmetrical. The circle is symmetrical. So 135 is a reflection of 45 across the y-axis. So the x-coordinate, it should have the same coordinates, but the signs will be different. The x-coordinate will be the same, but it will be negative. So it's negative square root 2 over 2, and the sign should remain positive square root 2 over 2. Now, this agrees with what we know about the second quadrant. Remember, in second quadrant, sine is still positive, but cosine becomes negative, so that's why it becomes negative. Okay? Alright, then let's take a look at the angle that's 30 degrees away from 90 and 30 degrees away from 180. Alright. So this angle is going to be 120 degrees, and this angle is going to be 150 degrees. Now you see 120 is a reflection of 60 degrees, so you will follow the 60, the value of 60. The y value will be the same. So the y value will be the same, but the x value also will be the opposite of 60 degrees. So it will be negative 1/2 and square root 3 over 2. So that means cosine of 120 is what? Cosine of 120 will be negative 1/2. And what about sine of 120? Well, sine of 120 is square root 3 over 2, the same as sine of 60. So this is the reflection. Okay. What about 150 degrees? 150 degrees has a reference angle of 30, so it's also a reflection of 30 degrees. So you can see why reference angles relates back to 30 degrees now. So the x coordinate will be negative because here I'm pointing to the left side, but the y side is still the same as 1/2. So that's how we go ahead and obtain the values of each of the angles here in the second quadrant. What do we do in the third quadrant? Well, we do the same thing, and we just consider the same reflection. Okay, so let's go ahead do this very quickly. Okay, so the angle between 180 and 270 would that would be 225 degrees, and the order pair, it would be a reflection of 45 degrees reflects across the y-axis and the x-axis. That means both of the values will be changed, because in third quadrant everything is well, both sine and cosine are negative. So the cosine value and sine value for 225 is both of them negative. This is the cosine value. Don't forget, the first x coordinate is the cosine value, the second coordinate, the y coordinate, is the sine value. Okay, so it's negative square root 2 over 2, both of them. Alright, what about the 30 degree away from 180 and 30 degrees away from 270? Okay. Alright, so let's look at the angle of 30 degrees away from 110. That's to 180. That would be 210 degrees. So 210, the reference angle 30, so you can see is a reflection of 30 degrees across the y-axis and across the x-axis. So it has to reflect twice, once, twice. Okay, so this has a negative square root 3 over 2 and negative 1/2. It follows the 30 degree angle. It follows the magnitude of the, or not magnitude, the measurements or the 30 degree angle, but in different signs. And here the 240 degrees, okay, let me see if I can screw up a little bit. 240 degrees, that's 30 degrees away from 270, and then it follows the 60 degrees is because the reference angle is 60, so it has a double reflection again from 60. Reflects across the y-axis, reflects across the x-axis, so everything is negative, so it's negative 1/2, negative square root 3 over 2. And as you can see, the pattern is quite clear right now. And if we go to the fourth quadrant, we'll again have an angle that's has a reference angle of 45 degrees, and then two other angles. One angle is reference is 30, and one angle is reference angle is going to be 60. Okay, so this first one is 300 degrees. Its reference angle is 60. So now in fourth quadrant, it's only reflection across down the x-axis. So the x value doesn't change, but the y value changed. So it's 1/2 and negative square root 3 over 2. All right. And for 45 degree, the reference angle for 45 degrees here, which is 315. Okay, so x coordinate doesn't change, so square root 2 over 2, but the y coordinate, the sine value changes negative. Alright, and for 330 degrees, the last one, this is reference angle for 30 degrees. Okay, the x coordinate doesn't change, but the y coordinate is a reflection, so it's negative. So there are so many ways that we can look at this. You can look at the reflections, you can look at the remember our acronym ASTC, all student takes calculus, okay, or all students take calculus. So every quadrant will follow those rules, and it doesn't matter however we look at it, we will come up with the same thing. So this is a rough sketch of a unit circle. Now let me show you one that's pre-made already. Okay, so this unit circle, okay, let's see if we can zoom in a little bit on this chart. Okay, so this is a unit circle that you can readily find online, anything like that. This gives you all the information you need, starting from this degree and the corresponding radian. So this is corresponding degrees and corresponding radian on the outside, and then it gives you the order pair on the circle, so that gives you the cosine and sine value for each of the angle. And using this chart, you can reference it very quickly. Now, if you don't have the unit circle, all you have to do is just remember the first quadrant, because if you remember the first quadrant, and you can always reflect them to the second quadrant, and remember the rules ASTC, then you can find out the angles for that have reference angle of 30, 45, 60 degrees in each of the quadrant very quickly. And again, remember to remember the cosine values. When you start from cosine 0, it goes from square root of 4 over 2. which is 1, then square root 3 over 2, square root 2 over 2, square root 1 over 2, and square root 0 over 2. So the cosine value decreases from 1 to 0, from 0 degree to 90 degrees. But the sine value increases from 0 degree to 90 degrees from 0, square root 0 over 2, square root 1 over 2, square root 2 over 2, square root 3 over 2, and square root 4 over 2, which is 1. Okay, so again, that's what we have to do to help us remember. Okay, all right, now let's one more thing before we go. Let's talk about what about the function of negative angles, which is very much related to what we're talking about here. But let's go ahead and draw a diagram here. Alright. Alright, so let's say I have an angle here. I'm going to use use blue here. Alright. So I have an angle here, and this is my theta, alright, and you have the x coordinate. In this case, of course, is positive, and the y coordinate, of course, they are positive also. So x and then y, right, and this is our r. Alright, so we have a point here, x, y. So the sine of theta will be equal to x y over r. The cosine of theta will be x over r, and so on. Okay. Now, what happens if we have a negative theta? Now, what do we mean by negative theta? Now, remember, negative theta means the rotation is in counterclockwise direction. Okay, counterclockwise direction. So this is positive theta in counterclockwise direction. The negative theta would be something like this. It will be rotating down. Okay, you'll be rotating in the opposite direction, so this will be negative theta. Alright, now as you can see, a negative angle, okay, in this case the y coordinate will become the opposite of y, because it now goes down. It's the same direction, but it now goes down, so it's the negative y. So the coordinate here is x, negative y. Alright, so let's go ahead and see what's the relationship between the positive theta and the negative theta. Alright, so the sine of the negative theta will be equal to a negative y divided by r. R will still be the same. So it's equal to a negative sine of theta, because it's opposite of sine of theta. Because you see, sine of theta is y over r, right? So negative y over r is just opposite of sine of theta. What about cosine of negative theta? Well, cosine, when you do the negative, when you rotate clockwise in such a fashion, here in this case x doesn't change, so still x over r, so it's still equal to cosine of theta. So that means if you do cosine of negative theta, it's still equal to cosine of theta. What about tangent of negative theta? Okay, well, tangent has to do with y over x, right? So it becomes negative y over x, so it becomes an opposite of tangent of theta. So tangent of opposite theta is equal to opposite of tangent theta. Alright, what about secant? Secant of negative theta or opposite theta is r over x, so that's the same as the secant of the regular theta. Alright, cosecant of the opposite theta will be r over y, but y becomes negative, so that means it's the opposite of the original cosecant of theta, or opposite cosecant theta. So cosecant of negative theta is the opposite of cosecant theta. And cotangent of the opposite theta is x over y, which is y becomes negative now, so this becomes negative cotangent of the regular theta. So what it means is there are several things we have to pay attention to besides, except for sine, except for cosine and secant. If you plug in an opposite angle, everything else changes to the opposite. Okay, only cosine and secant remains the same. So let me give you some examples before you go here. For example, sine of negative 25 degrees. Well, sine of negative 25 degrees is negative sine of 25 degrees, because that's what they are, okay? And cosine of, let's say, negative pi over 6, well, that will be the same as cosine of pi over 6, because cosine of the opposite negative pi over 6 and cosine pi over 6 are the same, okay? They are the same. Oh, I'm sorry. Let me go ahead and rewrite them. Okay. What about tangent of negative 130 degrees? Well, if it's tangent negative 130 degrees, it should be the same as tangent of, it should be the same as opposite of tangent of 130 degrees. Okay. Now, why is this important? Why do we want to do that? For example, let's go ahead and try this. Let's do secant of negative 30 degrees. Okay. So how do I find secant of negative 30 degrees? Instead of going to actually there are several ways to do this, but if we remember the rules for the negative angles, we know, oh, okay, this is just the same as secant of 30 degrees. It's just the same as secant of 30 degrees. Well, cosine of 30 degrees is square root of 3 over 2, so secant of 30 degrees is 2 over square root of 3, or we can rationalize it to become 2 square root of 3 over 3. Alright? You see how we can go ahead and find that, right? So what about sine of negative 240 degrees? Well, we know sine of negative 240 degrees is the negative, the opposite of sine of 240 degrees. And what is the sine of 240? Well, the sine of 240 degrees, we can use our unit circle, or we can think about this. Sine of 240 is the opposite of sine of 60 degrees, because that's the reference angle. Yes, sine of 60 degrees. So this is equal to sine of 60 degrees. 240 is has a reference angle of 240 degrees has a reference angle of 60 degrees, and this is in quadrant 3, so it's the opposite. And sine of 60 degrees, I think I remember that, is 1/2, so this is 1/2. Alright, so as you can see, we use several techniques, several facts to help us simplify and reduce this. So instead of looking up the unit circle, we can actually do this if we just remember sine of 60 degrees. But you do have to remember the rules and how to do that. Okay, let's try one more. Okay, now what about let's do cosecant. Let's try, or actually let's try cotangent. Cotangent of negative let's say 120 degrees. Okay, well, let's do 130 degrees. No, I'm sorry, 150 degrees. Okay, now cotangent of negative 150, so it's equal to negative cotangent of 150 degrees, and cotangent of 150 degrees is equal to sine over cosine over sine, because it's x over y. So it's negative cosine of 150 degrees divided by sine of 150 degrees. Okay, and cosine of 150 degrees was let's see, is the opposite of cosine of 30, so it's negative 1/2. Okay, no, actually no, negative square root of 3 over 2. And sine of 150 degrees is the same as sine of 30 degrees, which is 1/2. So this will become positive square root of 3. Okay, the 1/2 cancels out, and the negative times negative becomes positive. Okay. Alright, so we'll be doing a lot more practice like this next next time we come back in the next video lesson. But I think today this is where we should stop. And please leave any questions and comments, and please don't on the comment section, and please remember to subscribe and share with your friends about our videos, our video lessons. And if you have any suggestions or any other lessons that you would like to see besides trigonometry right now, let me know. I'll go ahead and then plan out the next series of lessons that we are going to produce for our students. Alright, thank you, and we'll see you next time.